Oftentimes, when we're dealing with information outside of our actual code, we're dealing with human-readable text that we've gotten from a file or are writing to a file or an input or an output stream. But sometimes human-readable text just isn't convenient, and we'd like to use information that's more computer-friendly. Through a process called serialization, we can take some Java objects and convert them to a binary stream that we can transfer across programs. This is not a human-friendly approach. As we'll see in this video, a serialized object looks like complete gibberish to us. But another Java program that knows about that object's class can recreate an object from that serialized information. Not all Java objects, however, can be serialized. In order for us to serialize an object, it needs to be marked as an object that can be serialized. And it needs to only contain members that themselves can be serialized. For some objects, those that depend on external references or those that simply haven't had all of their members marked as serializable, serialization is just not appropriate. The class in front of us, though, is a prime candidate for serialization. Its members are a number of strings and integers, both of which are classes that Java has marked as serializable. But in order for us to transform a car object into a binary representation, we need to let Java know that the car as well is serializable. We're going to need the I/O library for this, and then we're going to let Java know that our car object implements serializable. This is telling Java, yes, in fact, all the elements of the car object can be converted to binary representations. We should never tell Java that an object implements serializable unless we've looked at the object and thought it out and determined that this is a safe assumption to make. So we've now marked car as a serializable class, but that is of course the easy part of this video. Our next goal is to make use of this new functionality, to create a car object, serialize it, print it out to a file, and then read it back. To do this, we're going to create two new Java classes. One to serialize our object and print it to a file, and another class to deserialize our object and read it from a file. In both of these classes, we're going to create main methods so that we can run our classes as separate Java programs. Let's begin in the serialize class. The first thing we're going to need is an object for us to serialize. So let's go ahead and instantiate a new car object. Car takes 4 strings and an integers for its variables. It takes a vehicle identification number, make, model, color, and then a year. So we'll give it a number, a make, a model, a color, and a year. Once we've created our car, it's time to open up a file and serialize that car for output. When we open up a file in Java, we're going to use some different managers depending on if we'd like to write to this file formatted text output or if we're just planning on writing raw binary information. Because serialized objects are binary information, we're going to use a file output stream to write this information. File output stream is created with a file name to associate itself with. Because we're writing raw binary information, it's not that important that we specify this as a text file. We can specify it to be really whatever we would like. Our operating system really isn't going to know what to do with this file if it tries to open it anyway. We're going to want to surround all of this information in a try-catch block, because whenever we're dealing with external files, exceptions can definitely be thrown. If we do catch an exception, let's just simply print an error message. And noticing we're having to add a lot of imports here, let's just import the entirety of the java.io library. Now, I think we're good to move along. We've created our file output stream. And this stream is pretty good, but we can wrap it with another stream that's more specialized for the act of serializing a Java object. This is the object output stream. And we can construct an object output stream by simply wrapping it around an existing file output stream. Once we've created this object output stream and associated it with a file, serializing our object and writing it to this file becomes extremely easy. We simply need to use the write object method and provide as the object to be written our car. Once we write this object to our file, we should be responsible and close our output stream. And now I think we're good to run our program and see what happens. We have multiple main methods in this Java project. So as far as NetBeans is concerned, when we run our program, we should make sure to right-click on the class whose main method we want to enter with and run that file specifically. When we run this program, we don't really get any meaningful output because we didn't ask for any. At least an error wasn't thrown. But when we head to our directory in which this project lives, we'll see a new file, serialized.dat. If we edit this file with Notepad, it looks pretty ridiculous. This is certainly not human readable format. But there are some words or fragments of words that we recognize. It certainly looks like the correct object was serialized. Let's now head to our other class and attempt to write a method that will pull this car out from that file that we've written its serialized information to. Once again, we're going to need a car object, but this time we're not going to initialize it with a constructor value. Rather, we're going to set its value to be the object we read back from our file. The syntax we're going to use in our deserializer is going to look very similar to the syntax we have used in our serialize class main method. So actually, I'm just going to copy this over so that we can see the mirrored similarities as we build our deserialize main method. Oh, you know what? Made kind of a irresponsible error in this serialize method. We closed our object output stream, but we did not also close the file output stream. Now, this isn't really a big deal because our program immediately opened these files, performed its functionality, and upon terminating, Java destroyed these objects, and the files knew that nothing else was pointing to them. So our operating system is aware that these files are closed and can now be freely written too. But in a program that continues for a long time or even indefinitely, not closing a file can have some very weird consequences. When we're nesting file input or output classes like we've done here, we're generally going to close our files in the reverse order that we accessed them. In this case, it wouldn't make sense for us to call outfile.close before out.close because our object output stream for a brief moment there would be referencing a file that it could no longer access because the inner file output stream had closed. With that out of the way, we've copied our code over, and now we're going to make some modifications to it. So instead of serializing our object to a file, we are now reading the serialized object from a file. So instead of a file output stream, we're going to use its sister class, file input stream. I guess I should probably import java.io again. We'll want to be referencing the same file name here. And let's intelligently name our variables. In a similar manner, we're going to wrap this file input stream with an object input stream instead of an object output stream, still referencing the same file. Of course, this time, we have no interest in writing an object to this file. And that's good, because our input stream does not have the permissions or the know-how to write to this file. What it can do, however, is read an object from the file. Read object doesn't take any parameters. It's simply going to read whatever object happens to be in that file. And when it reads that object, we want to assign that object to our car C. Of course, read object only knows it's going to acquire an object from the file. It has no idea what type of object that will be. One of the weaknesses of serialization is that we really are forced to take a leap of faith and cast this object to the expected type. Once we've done that, it's simply time to close our file readers in reverse order. And there's now another type of handled exception being thrown, the class not found exception, which is thrown if our read object method fails. So let's catch this exception. Class not found exception. And to keep things simple and moving, we'll just throw or print out an error message like we did with the previous exception. Now, we need a way to tell if our program worked or not. So, at the very end, let's attempt to print out our car's information using its custom toString function. NetBeans is letting us know that this variable might not be initialized at this point in time. Some programming languages will let us make this mistake, and our car might not have been initialized because this try block could have failed. To let NetBeans know that we're aware of this case, or rather to let Java know that we're aware of this case, we should initialize our car C. We can simply initialize it to the value null. Now, it's time for our moment of truth. Let's execute this main method. When we run our file, in our console, we get the output a 2000 green Nissan Altima with this PIN number. That's the same car that we declared in our other main method and serialized to the file. Clearly, we have been successful. Serialization of objects is one of the things that Java does really elegantly and really well. It's an extremely powerful tool that can make one of the most difficult and frustrating tasks of modern programming, transferring information between logically separate entities of code, much, much easier than it otherwise would be.